So in today's lesson, we will be looking at simultaneous equations, and there are two methods of doing simultaneous equations. First, it's substitution, and then it's elimination. Now, here we see the first example, and before we get started, I just want to explain exactly what is simultaneous equations. So we can see we have two equations, and we also have two unknowns. So we have one equation here, say this is first equation and second equation, and then each of these contain an x and a y, an x and a y. Now what we need to do, or the goal that we need to achieve, is we need to solve for both of x and y. Alright, so in the first method, what we're going to do is we're first going to isolate one of the unknowns, and we can actually choose any of these four to isolate first, but what is most practical and what's going to work out the easiest is if you pick one that has no coefficient. So we can pick this one, or this one. That one has a coefficient, and if you pick that one, you're going to end up having to work with fractions. So let's maybe pick this one. Let's say we're going to isolate that one first. So what I'm going to do is I'm going to put x as the subject of the formula. I'm going to say, okay, x is equal to, so I take my y to the other side, then I get y minus 1. Okay, so I just put it in front. Okay, so now what we're going to do is we're going to substitute this. This is just our second equation rearranged, basically. So now we're going to say, okay, substitute equation 2 into equation 1. Right, so we can see that x is equal to y minus 1. And here we can see an x. So wherever you see an x in your first equation, you replace it with y minus 1. So y minus 1 goes in place of x, and then plus 2y equals to 5. So here all I did was just replace this x with the value of x I found in my other equation. And then we actually managed to get a linear equation where we only have y's to worry about. So now we can solve for y. So in normal linear equations, we take the y's to the one side, and we take our constants to the other side. So that's 5 plus 1. This becomes 3y equals to 6. Then we divide both sides by 3, so y is equal to 2. And then we still need to find x's value. This is quite easy now. We can just simply take our value for 2 and substitute it. You can either substitute it in one of these equations, but what would be easiest if you substitute it into this one where you already got y on its own, because now you can just say, okay, x is equal to 2 in place of y minus 1. So x is then equal to 1. All right, now we can also take a step further and just then write it in a coordinate. So your x value comes first, so that's 1, and your y value is 2. So this is then just your final answer. So this is always your x value and your y value. Right, so now let's look at the next example. So if we look at our variables, we've got an x, 4y, 3x, and minus 2y. So obviously the one that I'd like to isolate is the one that stands alone. That's going to be the easiest. So I'm just going to take, okay, this is my first equation and my second equation. So to put x on its own, I simply take 4y to the other side. Then I get x is equal to 14 minus 4y. Okay, and now I'm going to substitute equation 1 into equation 2. Now we see there's an x over here. So in place of this x, I'm going to substitute this in there. So this is going to be 3 times by 14 minus 4y minus 2y equals to 12. And then we multiply out the brackets. So 3 times by 14 is 42 minus 12y minus 2y equals to 12. Okay, solve for y. We take the constant over to the other side. So this is minus 12y minus 2y equals to 12 minus 42. So this is minus 14y equal to negative 30, and y then is equal to 30 over 14. The negatives cancel. We simplify it by just dividing both sides with 2, so that's 15 over 7. Right, now to get the x value, I'm just going to use this part over here. So x is equal to 14 minus 4, and then substitute in the y value as 15 over 7. And then we can just put that on the calculator to solve or to work that out. So that's 14 minus 4 times by 15 over 7. Okay, so that's 38 over 7. And we can end off by just writing in a coordinate. So 38 over 7 and 15 over 7. Okay, so this then was the first method. Now let's look at the second method. Now the second method I find slightly harder. Well, it actually depends on the type of sums you're working with. But normally this method is ideal if you actually have no x or y values that are standing alone. In this case we do have it, but we can also obviously use any method with any sum. It's just much easier if you have, like, if there was a coefficient here and here and here and here, then this method would be ideal. So the thing we're going to do is we're either going to add or subtract the two equations to eliminate one of the unknowns or one of the variables. So in this case, I can see that this coefficient is 1 and this coefficient is 1. This one is 2 and this one is minus 1. So what I can do here, if I need to decide am I going to add these or subtract them, if I'm going to add them, I'm going to end up with 2x. But if I subtract these two equations, then x minus x becomes 0. And then 2 minus negative 1, this becomes a plus. So 2 plus 1, because a negative and a negative gives me a positive. So 2 plus 1 is just 3y, and then equals, so 5 minus negative 1, so that becomes 5 plus 1 is 6. Then we divide both sides by 3, so y is equal to 2. All right, there we found y. Then to get the x value, I simply substitute it in any of these two. Always go for the simple one. So we have, or let's just go for the top one. Both are actually quite simple. So we have x plus 2, and then substitute in the value for y equals to 5. So x plus 4 equals to 5. X is equal to 5 minus 4, and x is equal to 1. All right, so then my answer there is 1 and 2. Okay, next example. Now we have this as our first equation and our second equation. So if I look at this or investigate this, we see that this has got a 3 and a 5. This one is plus 2 and minus 2. So this one's coefficients are identical or the same number. So I'm going to actually now decide, do I add them or subtract them? So if I add these two, if I just say 2 minus 2, then I get 0. So I'm just going to add these two equations. So 3 plus 5 is 8x. Then 2 minus 2 is 0 equals, and then 2 minus 18 is negative 16. Divide both sides by 8. Then we end up with x equals to negative 2. And now to find the y value, let's just substitute the x value into the first equation. So 3 times by negative 2 plus 2y equals to 2. Then this is negative 6 plus 2y equals to 2. So 2y equals to 2 plus 6. And then 2y is equal to 8. Divide both sides by 2, y is equal to 4. So therefore my answer is just negative 2 and 4. Okay, next one. So here we have 2 and 4, and here we have 3 and 5. So that's a bit of a problem because we can't either like add or subtract them to get them to eliminate. So what we need to do now is to see, can I times one of them to change it into the other one? Like for example, there's nothing I can times 3 with to make it 5, but I can times 2 with 2 to make it 4. So, but what I do on the one side, I have to do on the other side. I can't just times one of them. That's going to change the value. So I'm going to take this whole equation and times it with 2. So I'm going to times it with 2 and just write it down here. So 2 times 2 is 4x. 3 minus 3 times 2 is negative 6y. And then 10 times 2 is 20. So I just multiplied my whole equation through with 2 basically. Okay, now I can actually work with this. I've got a 4 and a 4. So if I subtract these two, I'll end up with 0. 4 minus 4 is 0. Then 5 minus negative 6. So a minus and a minus gives me a plus. So meaning 5 plus 6 is 11y. And then 42 minus 20 is 22. Okay, then we divide both sides by 11, so y is equal to 2. And then we just substitute my y value into one of those equations. So 2x minus 3 times by 2 equals to 10. So 2x minus 6 equals to 10. 2x equals to 10 plus 6. 2x equals to 16, and x is equal to 8. Alright, so my final answer for x, my x value is 8 and my y value is 2. Okay, now we're on the final example. So I look at my two equations and I can see that neither of the coefficients are the same. I can also see another problem, that I can't multiply 5 with anything to get 4 and vice versa. No, I can't multiply 4 with anything to get 5, and the 3 and the 4 work the same. So we need to take it a step further. We can't multiply, we can multiply them with each other. We can say if I multiply 4 with 3, I get 12, and if I multiply 3 with 4, I also get 12. So what I'm going to do is take this whole equation and multiply it with 3, take this whole equation, multiply it with 4, and then I can add or subtract my equations. So 15 times by 3, 5 times by 3 is 15y, and then we have plus 12x equals to 9 times by 3 is 27. And then underneath that, 4 times by 4 is 16y, negative 3 times by 4 is negative 12x, and 32 times by 4 is 128. Okay, now we can actually work with this one, where if we now decide, do I add or subtract them? I can see if I just add 12 minus 12, I get 0. So I'm just going to add these two equations. So 15 plus 16 is 31y, and that's equal to, if I add these two, I get 27 plus 128, and that gives me 155. Okay, divide both sides by 31. So we divide it by 31, and then we get 5. So y is equal to 5. Alright, now just a final step to get x. Let's substitute 5 into the first equation. Plus 4x equals to 9. Here we have 25 plus 4x equals to 9. So 4x equals to 9 minus 25. 4x equals to negative 16. So therefore x is equal to negative 4. Okay, so my answer is then negative 4 and 5. Alright, so that's done for the second method as well. So that means we are done with this lesson.